So number one, we're going to do a side one, and then we're going to do an angle one with algebra. So two pretty easy. We're just going to use the same picture. We could use that littler one. I don't think that's a word, is it? That smaller one, but it is tiny to try to draw in it. So let's just use this one. If you've done lesson 36, you had a problem in it, because I know some of them came by and asked me about it. I know Neely did in the other class, about when the Pythagorean theorem didn't come out exact. The one we did in our notes came out exact. The one we're going to do here is not going to come out exact. So we're going to call this one T, U, V, W, and this point in here is my Y, and I'm going to go ahead and put a right angle there. I mean, you can put it anywhere you want to, but I just automatically want to have a rhombus, and you can see it. They intersect at a right angle. We're given that UV is 8, and we're given that WX is 5. You don't put a bar above them when you're talking about their numbers. We want to know TU. We want to know WU. We want to know TX, and we want to know TV.
What is X?
There isn't an X. That's a good question.
Yeah.
Oh, this is, okay, what? Oh, I used a Y for something else. I'll show you in just a minute. I think I was helping somebody. It may have been, was it Abby? Was it you that we put the Y on there when we were working one this morning? Yeah, that's what my notes are. That's the X right in the middle. Thank you, Kim. I'll show you what I'm talking about. Because it has an X in it, I don't like to use an X in my Pythagorean theorems where it's going to come up. UV is 8, and WX is 5. So I know that, just for me, I'm going to go ahead and label XU as 5. I don't know these two little pieces because I know they're equal, but I don't know what they are because this is a long diagonal, short diagonal. I know all the sides are 8. Now, does it ask any of that? TU, yeah, we know that's 8. WU, do we know it? Yeah, what's that? 10. And then TX is going to be our unknown, and that's what Abby and I were talking about this morning. When I need a variable, and I've got an X in the problem, even though that's a capital X point, I'm going to use the little letter Y for my unknown in my problem. Okay, now you got to use a right triangle because that's really about all you got. If you want to know this Y right here, you can either use this one or this one. I used that one last year, so I'm going to trace this one a little bit darker. And if you don't have the right angle thing there, go ahead and put it there. And actually yesterday in regular, I redrew the picture, just sketched it. I didn't use a geometer, but I know the hypotenuse is 8. I know this leg is 5, and I'm calling this leg Y. Just as review, Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. Now, very rarely on the ACT, the ACT is supposed to be calculator neutral, meaning you don't have to have a calculator when you do it. And I know that kind of blows your mind, but it is very real. And they very rarely would give you one that would not come out even. They would give you one that's obvious, and there's actually some real obvious ones that we'll talk about a little bit later. Pythagorean triples, I don't know if we addressed those when we had them, but we'll come back, and especially for the sophomores, we'll mention some of that stuff. So leg squared, I'm going to do y squared plus 5 squared equals 8 squared. Y squared equals 25. Y squared plus 25 equals 64. Minus 25 minus 25. Y squared equals 39. Now, honestly, if it was just me and I wasn't doing links, I would probably, when I do square root, because we've been doing these in Algebra 2, I would just leave it square root of 39. Square root of 39 won't break down. You know, if you have square root of 12, it's 2 square root of 3. We've done a lot of that. But if you're talking about the length of something, you know, I'm not going to say, well, the length of this is 2 square root of 3. You're not going to say that. You're going to say, you know, approximately, or it's about, you know, 16 inches or whatever. You're going to approximate it, and that's why they want the approximate. So y, and I'm going to put that's just the teacher in me. I'm going to put the approximate symbol. That lets me know I'm rounding. If it doesn't say, tenths is always the best for me, 1 decimal place. So if you got your calculator handy, I'll do it for you. You want to know where that square root key is? It's on the squared, right above it in blue. So second square root. And we're going to do, and this actually showed up real well on the video. I was surprised. 39, enter. It does show parentheses, and you're supposed to close it, but you really don't have to. So I don't always do it. You get 6.24499. This 4 is going to make that 2 stay the same. So we're going to say about 6.2, whatever the units are. And that actually is our TX. Now, if you take that, now here's what's kind of interesting. Because if you leave it, if you look at that and you double it for TV, see if this is 6.2, if this is about 6.2, that's about 6.2. So it looks like it's about 12.4. But I'm going to tell you, it's kind of interesting here that if you leave the exact answer, that is the square root of 39, rounded off here, but it's irrational. And if I go times 2, it actually rounds to 12.5. See, it's kind of interesting. So your rounding affected. So I'm going to put or 12.5. Now, mathematically, that's the best one. It's more accurate that double whatever that was before it was rounded. You really should only round once in a problem. You know, you're doing this humongous chemistry problem, and you don't want to round until the very last step. Because see, what happens is we rounded, and then it made this answer off just a little bit. So this is the correct answer. I would accept both because I get what you're doing. But this is actually the best one. Okay, everybody good? Did that answer everything? Okay, number 2. Same picture. I think, no, I started to say it's the same letters. It's got some of the same letters, but not all the same letters. Oh, this one's got a little thought to it. I like those. It says W, X, Y, Z. And I actually don't even have a letter in the center. I guess we don't need one, but I'm going to put my little right angle there. And I've got measure of angle X, Z, Y is equal to 10x minus 8 degrees. And we've got the measure of angle X, Y, Z okay, give me just a second. Now, what is that in there? X, Y, Z. I don't even need that. I don't even know why that's in there. The measure of angle W, Y, Z is 68 degrees. I'm trying to figure out why oh, I know what it was. Okay. Well, we'll just leave it. I'll just leave it like that, but I'm going to show you what they actually did. What they did, they didn't give me this. They gave me this whole one was 136, and then I know that the diagonal bisects it, so if you divide 2 into 136, that's where you get the 68 right here and the 68 over here. So that was a little extra work that I did for you. I didn't realize 68 degrees. And this little corner right here, X, Y, Z, X, Z, Y is 10x minus 8. And I may can zoom in on that just a little bit for you, because then I'll get it out of the screen, but and I think they're only asking for X. You know, they could ask for X and then ask you to plug in. But wow, this is a great one. What? And there's actually a couple of ways to work it. Let me talk about the way I first thought of it, and I'm going to actually do this for you and see if that helps you. And you tell me what equation I could say. Now we're doing degrees. We're not doing sides, so it's not Pythagorean theorem, right? It's angles of a triangle. Now what do we know about the angles of a triangle? They all three equal 180. Now there's a shortcut to that one, but I'm just gonna write it what you just said. So you're saying 10x minus 8 plus 68 plus 90 is 180 degrees. All three of these angles add up to 90. Let me try that again. All three of them add up to 180. Now here's the way I thought it. Instead of counting that one, if that one's 90, then these two have to add up to 90. So I just did that plus that equals 90. It's going to be what I'll have after I do the arithmetic. But if you do it this way, you have, let's see, we've just got 10x, and that's going to be 80. I think that's going to be 170. Oh, is that right? 168. How about one? Okay, negative, that's 60 plus, I can't add, 150 equals 180. There we go. Negative 8 plus 68 is positive 60, and 60 plus 90 is 150. Now we got it. Okay, yep, because I zoomed in, didn't I? X equals 3. Now, I had a student yesterday in my afternoon algebra 2 class that's like, don't confuse me, don't give me extra information. Another way you could have gone, because you knew all of this was 100 and, what do we say, it was 136, then all of this one and all of this one add up to 180. See, you could have done that because these two are the same. So that would have been another option. So you've got a couple of different ways you could have gone. I think the work is going to be the same, but I just used the triangle. But these love to use the Pythagorean theorem because these little triangles are your right triangles. That's the only way you're going to get a right triangle out of the rhombus. You only have 5. They have quite a few parts to them, but still, they're like what you've been doing. There's just a few of them. There were more. I wasn't that crazy about them, so I just did the ones, and that'll make you happy. So you got 10 minutes. I'm going to go grade.